Hi all, my name is Amjith, yes, Professor in Electrical and Electronics Department, Mahaguru Institute of Technology. Today we are going to discuss about basic electrical engineering. So, in basic electrical engineering, we will discuss about charges. We know there are two types of charges. One is negative charge and the other one is positive charge. You are familiar with these type of charges in your previous classes. So, what is the properties of charges? We know light charges repel each other. If I place these charges, two similar negative charges placed in here, it will experience a force which will tend to repel each other. If I place a negative charge and one positive charge in here, so they will try to attract each other. So, what is the definition of current? What do you mean by a current? Current is the movement of charged particles. The correct definition is movement of charged particles. So from the beginning, let's go to the atom model, Bohr's atom model. So in there, we know that the nucleus consists of protons and neutrons. So the nucleus is at the middle of that atom. It consists of protons and neutrons. We know protons have positive charge, neutrons have no charge. So, and electrons are revolving around the nucleus. So, the electrons are represented by here and here. So, it is similar to solar. So, it is similar to solar system. So the electrons are revolving around the nucleus. The electrons have negative charge and protons have positive charge. The movement of charged particles, that is meant by a current flowing around. Then the electron is spinning itself. It is considered as a current, and the electron is moving around the nucleus. It is considered a current path, and the proton is revolving or it is spinning itself. It is considered as another current. So in current definition, the current is the flow of or movement of charged particles. In equation, we can write it as, in mathematical expression, it is the rate of change of charge with respect to time. So dq by dt. Current is defined as the rate of change of charge with respect to time. The phenomenon of transferring charge from one point in a circuit to another is called as electric current, or we can say it as the rate of change of charge with respect to time. The change with respect to time of a charge. It is termed as a current. The unit of current is the ampere. Unit of current is ampere. Or what is the unit of charge? It is coulombs. Time in seconds. So we can define as coulombs per second or ampere. So let's go to the electron drift velocity. Electron drift velocity. What do you mean by electron drift velocity? So suppose that in a conductor, the number of free electrons available per meter cube of a conductor material is n, and their axial drift velocity be v meter per second. I am considering a conductor. It is similar to wire. I am taking a small portion of wire. It is called conductor. So it is a small piece of conductor, and a small volume I am taking here. So in that volume n number of free electrons are present and it moves a velocity, I mean axial velocity. It is not the electrons can move any directions in here. So I am taking the velocity of axial direction. That is mean by axial velocity. V be the axial velocity of that electron, free electrons. So n number of electrons per meter cube and V be the axial velocity of that electrons. We have to find out the electron drift velocity. So for that I am considering a small portion of conductor like this, and n number of free electrons per meter cube, and these free electrons move at a velocity of axial velocity of v meter per second. So in time dt, I am representing time as dt because it is very small time. In time dt, the distance travelled by the electrons will be v into dt. Okay, if the cross-sectional area, I will shade that cross-sectional area. So let it be the cross-sectional area capital A. If A is the cross-sectional area of the conductor, then the volume is V A dt. V is the velocity and A is the area, cross-sectional area of the conductor, dt is the time taken. Okay, the number of electrons contained in this volume is n. So obviously all these electrons will cross the conductor, cross the cross-sectional area in time dt, time in dt seconds. If E is the charge of one electron, then total charge which crosses the cross-sectional area is at a time dt is dq, which is equal to number of electrons into cross-sectional area into charge of one electron into velocity of that electrons into what? Into time. This is the total charge. I mean charge is the total charge is dq. Charge of one electron is E, and then total charge is number of electrons into E cross-sectional area into charge of one electron into velocity of that electrons into time dt. So we know what is current, what is the equation for current. Current I is equal to rate of change of charge with respect to time, dq divided by dt. We will get n a e v dt divided by dt. So we will get equation as n a e v. The unit of current is amperes. NaEV amperes. So let current density, let J be the current density. So J is equal to what is I by cross-sectional area A. You will get N E V ampere per meter square. This is the unit and this is the equation. J is equal to N E V meter per second square. So for a copper conductor, the AB is equal to 1.55 into 10 raised to 6 ampere per meter square, and number of electrons, free electrons be 10 raised to 29, and charge of one electron is 1.6 into 10 raised to minus 19 coulombs. To find out the electron drift velocity, I just put these values in this equation. Then you will get V is equal to So I am going to put this equation number 1, then 1.55 into 10 raised to 6 is equal to number of electrons is 10 raised to 29 and charge of 1 electron is 1.6 into 10 raised to minus 19, then into V. So we will get V is equal to 9.7 into 10 raised to minus 5 meter per second or 0.58 centimeter per minute. Velocity, the electron drift velocity of that material or that free electrons. So you may be seen that the contrary to the common but mistake view. The current velocity is not like this. We know if I stand in here, I have a switch in here and a distance of 3 lakh kilometer far from me there will be a bulb. If I put switch, turn it on, then at the same second the bulb will glow. What is the difference between these two velocities? This is electron drift velocity, then this is velocity of field propagation. We know the velocity of field propagation is the velocity of same as that of light. If I turn a switch in here, the bulb will glow at a distance of 3 lakh kilometer apart from me. At the same time, the speed with which charge drift in a conductor is called velocity of charge or velocity of propagation of electric field. This is velocity of charge. This is not the velocity of current or that field. This is only the velocity of charge. It travels a few centimeters per minute or few millimeters in a second. So from here we can conclude that the velocity of charge is different than velocity of that current. The current or the speed with which the effect of EMF is experienced in all parts of conductor resulting in the flow of current is called velocity of propagation of electric field. I mean, if you turn on a switch, then at the same moment you can see that the bulb will glow. This is the velocity of propagation of electric field. It is equal to 3 lakh kilometer per second or 3 into 10 raised to 8 meter per second. Or I can say the current or the electric field travels at a velocity of 3 lakh kilometer per second. Within a second it travels equal to the speed of light. That's the difference between electron drift velocity and velocity of propagation of electric field. For example, I will give you one example. So suppose I have water connection from government. They have water tank in somewhere. So this is my house. So I take a water connection here. If I turn this tap, water tap, I will get water at the same moment. But it doesn't mean the water molecule that I got is not traveled from this water tank at the same time. The water molecules in the water tank travels a few centimeters or few millimeters at that present. But the total effect is traveled very fastly. That's the difference. We will take the same aspect in electric field also. So the electrons are present in all conductors. So the current flow doesn't mean that the free electrons in here doesn't move at a speed of 3 lakh kilometer per second through this. Doesn't travel through this. Maybe it will travel few millimeters at that moment. The field will travel 3 lakh kilometer per second. That's the main idea behind this. Next we will discuss about resistance. What is resistance? It is simply that the property of a material, or it is defined as the property of a substance to oppose the flow of electricity. It is a property, or it is defined as the property of a substance to which it opposes the flow of electricity. If a conductor has some resistance, it means it will oppose the flow of electrons through it, flow of free electrons through it. It will offer some resistance. What is the unit of resistance? It is called ohms. This is a unit of resistance. So once more, resistance be defined as the property of a substance due to which it opposes the flow of electricity through it. That's the definition. So resistance, the unit of resistance is ohms, and multiples and submultiples of ohms are mega, kilo, centi, milli, micro, etc. So what are the laws of resistance? First one is, it varies directly as its length. If a conductor has L centimeter length, so its resistance varies directly proportional to its length. Resistance directly proportional to its length, and its resistance inversely proportional to the cross-sectional area of that conductor. If this conductor has cross-sectional area, I am shading that area BA. The resistance inversely proportional to the area, cross-section area. This is the cross-section area. The resistance inversely proportional to the cross-section area of that conductor. And the resistance depends on the nature of material. So we have a lot of type of materials in surroundings: gold, metals, gold, iron, copper, aluminum, etc. All have different types of resistance because these materials have nature of material is different one each other. And fourth point is, it also depends on the temperature of the conductor. The resistance is proportional or inversely proportional to the temperature. It depends upon temperature of that material. These are the laws of resistance. You should know the basic laws of a resistance. It is directly, the resistance of a material directly proportional to its length and inversely proportional to the cross-sectional area of that. And third point is, it depends, the resistance depends upon material. And last point is, the resistance depends upon temperature. It may be positive or it may be negative temperature coefficient. We will discuss it in later. So you should understand these basic terms. Let's moving on to the next topic, resistivity. We know resistance, from these laws we can write R proportional to L by A. L is the length of that conductor, A is the cross-sectional area of that conductor. So to change proportionality, we will multiply with a constant called resistivity or specific resistance, rho L by A. Rho is called resistivity or specific resistance. So we know the units: resistance in ohms, L in meters, area in meter square. So what is the unit of resistivity? What is the unit of resistivity? Rho is equal to, from this equation we can rearrange it as R A by L. So you will get the resistivity is ohm meter. The unit of resistivity rho is equal to ohm meter. This is the unit of resistivity. So similarly, we can also find out the conductance. The reciprocal of resistance is conductance. Next topic is conductance. What do you mean by a conductance? It is represented as capital G. It is simply the reciprocal of resistance. G is equal to 1 by R. So you can easily understand the equations. R is rho L by A. We just put it in here. Then 1 by rho A by L. 1 by rho is called sigma. Sigma A by L. Sigma is called conductivity or specific conductance. Sigma is called conductivity or specific resistance. So G is a conductance. Its unit is Siemens. In old era, we consider as mho, MHO. Now its unit is Siemens. Siemens or mho, or we can represent it is like. So 1 by ohm. These are the main units of conductance. Conductance is the reciprocal of resistance, and 1 by R, it is 1 by rho into A by L. 1 by rho is termed as sigma. Sigma is specific resistance. I hope you can understand these terms. So let's study some properties of or effect of temperature on resistance. What are the effects on temperature on resistance? So the effect of rise in temperature is to increase resistance of pure metals. The increase is large and fairly regular for normal range of temperature. The temperature resistance will be like this. There are two types of materials: positive temperature coefficient and negative temperature coefficient. I mean, positive temperature coefficient means that increase in temperature result in increase in resistance. The negative temperature coefficient, increase in temperature, means decrease in temperature. If I am taking a material, it has a positive temperature coefficient. Suppose I am heating it, then its temperature increases to normal degrees to some higher degrees, maybe 100 degrees Celsius, then its resistance also increases. Suppose it has at 30 degrees Celsius, it has 50 ohms. At 100 degrees Celsius, it will become 100 ohms. It is positive temperature coefficient materials. The another classification is negative temperature coefficient materials. It means the increase in temperature results decrease in resistance. If at 30 degrees Celsius it has 50 ohms, at 100 degrees Celsius its resistance becomes 1 or 10 ohms. Here you can see the changes. There are two types of materials. One is positive temperature coefficient and the other one is negative temperature coefficient materials. So we know the basic laws of resistivity. It is that the temperature, the resistance is temperature dependent one. Okay, thank you.